Alright, in this video we want to talk about graphing special functions, linear functions, functions that will graph a line. Okay? So the first thing we need to talk about when we start talking about linear functions is the concept of the rate of change in a line. We call it the slope of the line. Slope is the mathematical description of the grade or the percent incline of an increasing or decreasing function. So slope, actually, we can use a ratio to explain what's going on when you're measuring slope. It's the ratio of the amount you go up or down, which we call the rise, over the amount you go to the right, so the run. Rise over run. And that's how I always measure it. I always talk about how much you would go from one point to the other, how much you would go to the right, and the amount you go up or down. So if you go up, we'd have a positive slope. If you have to go down to find the next point, then you would have a negative slope. It's easier to memorize up or down than left and right. So I always measure to the right on top, on bottom, up or down on top. Here is a formula that we use to measure slope. You have, I know, seen this formula probably in lower or elementary algebra courses. y2 minus y1 over x2 minus x1. Now this refers to if you're given points. If you're given 2 points on the line, you can use this formula to find the slope. Little m is always used to denote the slope. Probably no matter what textbook you use, they always use the little m to represent slope. So here's a problem they want us to try. Find the slope of a line that contains the 2 points, 2, -1, and -3, -6. So what you can do to kind of make sure that you have your information organized, you can label your points. I'm going to label this first one x1, y1. That ordered pair both have the subscript 1. That's not an exponent, it's just a name. And then the point -3, -6, we're going to label that as my x2, y2. So if we want to use the slope formula, which was y2 minus y1 over x2 minus x1, then we know what numbers to plug in where. So y2 is -6 minus y1 is -1, so minus -1 over x2 minus x1, so that would be -3 minus 2. So now to work that out. On top, -6 minus -1, we know that's going to end up being +1. So -6 plus 1 is -5. Over, on bottom, you have -3 minus 2, which we know is also -5. So what happens there? -5 divided by -5. The slope of that line that contains those 2 points would just be +1. +1. Now, in part B here, we've got the same thing going on. Find the slope of the linear function that contains the points f of 2 equal to -5 and f of 0 equal to 3. Now, the only difference is we didn't write our points in an ordered pair form. They're kind of given in a function domain range form. So in this point, f of 2 equals -5, your x would be the 2, your y would be the -5. And then f of 0 equals 3, your x would be the 0, and your y would be the 3. So again, I'm just going to label these like we did in the previous problem. So I'll call this x1, y1, and x2, y2. So in the same way, we can calculate the slope. So y2 would be 3 minus y1 is -5, so minus -5 over x2, which is 0, minus x1, which is 2. So on top we have 3 minus -5, which we can know is addition, so that's 8, divided by 0 minus 2, which is -2. So 8 divided by -2 gives me -4 for the slope. Horizontal and vertical lines. An equation of the form y equals b always intersects the y-axis at the point 0b. The line with that equation is horizontal and has a slope of 0. So if you get an equation that's just y equal to a number, a constant, then you're going to have a horizontal line and it has a measurable slope. The measure is 0. And a horizontal line would be an example of a function because If you were to draw vertical lines through it anywhere, you would only pass through 1 point. So it would pass the vertical line test. Now, if you get an equation of a line that is of the form x equals a, or x equal to a number, it always intersects the x-axis at the point a0, but it's a vertical line and it has an undefined slope. Vertical lines, of course, would not be functions. Because, of course, if you drew a vertical line through a vertical line, you would intersect every single point on that vertical line. So, therefore, vertical lines are never examples of functions. Horizontal lines are examples of functions. And just a reminder, a horizontal line does have a measurable slope. It's measured at 0. You cannot even measure the slope of a vertical line. It's considered undefined. Some books might even say that the slope is no slope. Now, let's just graph a couple of these just to kind of get an idea of what we're talking about. If I gave you the equation, let's say y equals 5, or f of x equals 5. That's a horizontal line, and it's going to go through the point 0, 5. So it's going to go through the 5 on the y-axis. So here, this is the graph of the function y equals 5. Now, if I were going to graph the equation, let's say x equals minus 3 or negative 3. That is not a function, but you could still graph the vertical line. The vertical line is going to go through negative 3, 0 on the x-axis. So there's your equation of your vertical line. Now remember, that's not a function. Okay? If your equations of your lines have been solved for y in terms of all the other variables, they're in what we call the slope-intercept form. Slope-intercept form of the line. Y equals mx plus b. The number in front of the x should always be the slope. And then the constant, we use b, is always the y-intercept of the line. So these graphs can be put, you can graph one of these equations if it's a linear function. If you have solved it for y already, it can be graphed very quickly in a coordinate plane using these guidelines. You can graph the line directly from this form by plotting the y-intercept first. So whatever this number is right here, we're going to plot that on the y-axis first. Then using the slope to find other points on the graph. So we know slope is rise over run. So whatever the number in front of x is, we're going to use that ratio, the rise on the top, the run on the bottom. Let's write that in here just to make sure you remember what that is. Rise over run, to help us graph other points on that line. So let's look at some examples of how that would work. This linear function, f of x equals 1/2 x plus 4. Now remember, f of x means y, so y equals 1/2 x plus 4. So in this case, the y-intercept is the positive 4. So that's the first thing I'm going to graph. I'm going to graph positive 4 on the y-axis, so I'm going to plot a point there. Okay? Now, the number in front of the x, the coefficient of the x, that is the slope of the line. 1/2. So if the slope is 1/2, that means the rise is 1 and the run is 2. So from the point we've already plotted, we plotted the y-intercept. We're going to use the slope over 2. The run is 2, so over to the right 2. So 1, 2 units. Hold your pencil there. And the rise is positive 1, so we're going to go up 1. So I can continue to do that pattern. Over 2, up 1, as many times as I want to. Then we are able to just connect the dots and graph the linear function. So it's pretty easy if it's in the slope-intercept form. If it's a linear function in slope-intercept form, then it's pretty easy to just graph it outright. Here's another one. F of x equals negative 2/3 x plus 1. So this is in y equals mx plus b form. So the y-intercept is positive 1. I'm going to plot that on the y-axis. Go ahead and do that step. And then the slope of this linear function, the number in front of the x, is negative 2/3. So the rise, if you've got your rise being negative 2 over the run being 3. So on the point that we've got plotted, we're going to go over 3. 1, 2, 3 to the right for my run. And since it's negative 2, I'm going to go down 2. 1, 2, and plot a point. I can do it again. Over 3 to the right, down 2. And you can continue to do that as much as you like. Then you're able to graph the linear function. Forgive my curvy line there, but I'm not using a ruler or a straight edge to get that. But you get the idea of what we're talking about. In this equation, f of x equals 3, this is like saying y equals positive 3. Notice there's no x. We looked at this earlier in this lesson where we say if we have y equal to a constant, that it's going to graph a horizontal line. So this would be a linear function. It would go through the point 0, 3 on the y-axis. Since the slope is 0, we're not going to go, we can go over anything we want to, but we're not going to go up or down, so it's going to graph a horizontal line, which is still a linear function. Okay, this is not in function notation, but we know if it's solved for y that it is a function, mx plus b, so my y-intercept is negative 3 again. Plot that first. The slope is 2, but we're going to interpret that as 2, let's say 2 over 1, like a fraction. So from the point you've got plotted, I'm going to go over 1 to the right and then up 2. Over 1, up 2, over 1, up 2. You can do that as many times as you would like. And then connect the dots and have your linear function. Now sometimes you're given the equation of the line and it is not in function form. This is not in function form. It's actually not in standard form either, because we know in standard form you can't have the negative as your first variable. But we could get this in function form. All we would have to do is algebraically solve this equation for y in terms of everything else. So that's what we're going to do, just kind of review that process. I'm going to add 2x to both sides. So then I have 4y equal to 2x plus 8, because you can't combine those on that side. They're not like terms. You can't combine them. So now to get the y alone, I'm going to divide by 4. So what I need to do is divide everything by a 4. So we get y equal to 2/4, which we will reduce to 1/2 x, plus 8/4 is 2. So we could just divide that and get 2. So in this case, a linear function, my y-intercept is positive 2. My slope is 1/2, so I'm going to go between my points. I'll go over 2, up 1. So over 2, up 1, over 2, up 1, over 2, up 1. As many times as you'd like to plot some points. Connect the dots. And we have our linear function. Notice that these lines that we've been graphing would all pass the vertical line test, so they are linear functions.